Hello, my name is John Robbins. Thank you for tuning into my video about episodic memory, the systems, the mechanics, and the deficits involved. To start with some learning objectives, what I would like you guys to take away from this video is an understanding of different memory types, examples and differences of memory types, the definition of episodic memory, also understanding memory systems, the neural architecture, memory formation, as well as memory mechanics, formation, consolidation, and retrieval, and also understand memory deficits, specifically confabulation, examples, causes, mechanisms, and implications. Jumping right into memory types, there's short-term versus long-term. We'll be focusing on long-term, but um, just to mention, short-term memory has a limited capacity. It's information is recalled immediately. It's information's only can only be held for 15 to 30 seconds, with the average number of items being seven. Long-term memory is the recall of information after a delayed period of time. It's durable, it's long-lasting. And within long-term memory, there's explicit, also known as declarative, and implicit, also known as procedural. I have an image of tomatoes here because semantic knowledge is general facts and knowledge about the world, which would be tomatoes are usually red, grow on vines, are edible. Episodic, when I was 9, I had a cherry tomato. I gagged. I don't like to eat cherry tomatoes anymore. I have an image of a man riding a bike for implicit because implicit memory involves skills, conditioning, and habits, things we don't have to think about while we do. Going in, before we go any further, I'd like us to just give a brief overview of what we're talking about, the neural architecture of episodic memory, the regions involved, how they work, and how they are strengthened and weakened. So jumping right into the brain regions, there's a bunch here, but we'll be focusing mainly on the prefrontal cortex as well as the hippocampus. Prefrontal cortex circled in gold here allows for memory monitoring and verification, also the organization of memory content. The hippocampus circled in a nice little salmon here is the primary coordinator for conscious memory formation and also allows for spatial and temporal context of experiences. Before we go any further, I just wanted to give a brief uh, overview of neurons. There's hundreds of millions of neurons in our brains. They are the signals that allows our brain to communicate within itself and function. Um, if we look to the upper right here, without getting distracted by the other image, the dendrite that allows for signals to be received. The nucleus is like the brain of the neuron. The soma is the cell body. The axon is what allows the signal to travel through. This is the path the signal will travel, and the axon terminal allows for the output of that signal. Now, long-term potentiation, that's rapidly and repeatedly activating synapses to make them stronger. So basically, neurons fire an action potential. Um, Neurotransmitters are released. They bind to the postsynaptic receptors, and then ion channels allow for electrical currents to flow in and out. Um, it's a bit confusing, but basically, it's widely to be considered the basis of learning and memory, um, specifically synaptic strength in hippocampal neurons, especially for memory. Hebb's rule I have here. Donald Hebb in 1949, scientists theorized that cells that fire together wire together. Basically, cells can become associated if they fire together consistently um, and are strengthened, uh, which is what's shown in long-term potentiation. These neurons that fire together wire together and become stronger. Now that we've talked about neurons, we'll be going into memory formation. So the first we'll be talking about encoding, and be talking about consolidation and storage, and then we'll be talking about retrieval. Now the encoding process. Initial processing is in the hippocampus. Could be thought of as like the memory gateway. And then the prefrontal cortex receives input from the hippocampus and deciphers what's worth remembering. This is the first step to memory formation. Here, this is showing also retrieval, which is the third step. But uh, information is processed and is encoded into um, is encoded into long-term memory. Consolidation and storage. Before we jump in, I'd like you guys to look at this image on the upper left here, just a basic overview of consolidation, memory consolidation, information, incoming information here. So, you know, a smell, a taste, a touch. We have sensory buffers in the brain. This information is encoded to the hippocampus, and then once consolidated, it leaves the hippocampus to the cerebral cortex. So initial memory traces are held by temporary synaptic connections in these neurons. Sleep, repetition, and retrieval practice replays neural patterns to strengthen these connections. And once these connections are strong enough, memory shifts from the hippocampus to distributed cortical networks. This image on the bottom right here by Killingzing et al. From 2019 is showing the memory shift from the hippocampus to the distributed cortical networks. In this figure A here, we're seeing there's a lot of lines. The blue is the hippocampus, and these red nodes and the lines are the cortical networks. Well, the lines are the connections, um, the neural connections. Um, Once sleep, repetition, and retrieval strengthen these patterns, they no longer are connected to the hippocampus, making the memory consolidated. On to retrieval. So a cue, which can be either voluntary or involuntary, so actively trying to recall something, or a sight, a smell, a taste makes you think of something, activates. This would activate the neural networks in the hippocampus. The prefrontal cortex then directs attention to relevant information and suppresses distractions. And eventually, the hippocampus and prefrontal cortex work together to reconstruct the memory. Just a quick little memory in motion, short-term memory encoded to long-term memory, long-term memory. Uh, the This is more rehearsal or retrieval. The hippocampus memory gateway, it allows for memory to be encoded, and these guys, the prefrontal cortex, uh, uh, executive function describes what information is good, what's bad. The anterior cingulate cortex was not mentioned yet, but it signals cognitive control for suppression. It works with the prefrontal cortex to pick what's right and what's not right, what information is relevant and what's irrelevant in our memory for the situation. We've also been talking a lot about the hippocampus, so I just wanted to give a brief overview of the anatomy of the hippocampus. To start, we have the dentate gyrus, which is the first region of the hippocampus circuit, known for pattern separation and the creation of new neurons. The CA1 receives input from the CA2 and the CA3. It projects to the subcolum. And this is known for long-term memory formation and retrieval, as well as spatial memory and navigation. Um, the CA2, which is not very well known, but is thought to be involved in social memory and the temporal coding of events. CA3, which receives input from the dentate gyrus, projects to CA1, and that is known for pattern completion, basically retrieving memories from a partial cue and learning relationships in context. The CA4 is within the dentate gyrus, is known for novelty detection and pattern separation. And finally, the subcolum, which is thought to be the output region of the hippocampus, receives input from the CA1 and projects to various brain regions. specifically the prefrontal cortex. This is known for spatial navigation, consolidation, and decision making with the help of the prefrontal cortex. Moving on to confabulation, or more broadly, memory deficit. So, what is confabulation? The American Psychological Association defines confabulation as the falsification of memory in which gaps in recall are filled by fabrications the individual accepts as facts. So, could also be misremembering, but without the intention of lying. It's very important. There's four different types. There's spontaneous confabulation, which occurs without a trigger or cue. An example of this would be a person with Alzheimer's disease might talk about a fictional pet they don't own. Provoked confabulation. This happens when a person is prompted, often filling in the gaps with fabricated details. An example of this would be a person with Korsakoff syndrome saying he went fishing last weekend when he stayed at home. Momentary confabulation, brief and fleeting instances of false memories, often occurring in response to a specific question. An example of this would be a traumatic brain injury patient might believe their nurse is a family member when asked who they were. Fantastic confabulation, elaborate and often fantastical false memories. An example of this would be a schizophrenic patient might claim to have traveled to another planet or possess superpowers. So causes of confabulation. There's not one known cause to confabulation, although there are some big predictors. Uh, First being Korsakoff syndrome, which is usually but not exclusively associated with alcohol misuse and severe alcohol abuse disorder, characterized by confusion, lack of energy, lack of muscle coordination, vision problems. Alzheimer's disease, it causes onset to dementia. It's a biological process which begins with the buildup of proteins in the brain, causes cells to die, forgetfulness, changes in mood and behavior, changes in sleep patterns, um, social isolation are all symptoms. Um, Traumatic brain injury, brain injury caused by sudden traumatic force, big hit, pen, blunt force object, um, something breaks the skull, um, and schizophrenia, which is characterized by delusions, hallucinations, disorganized speech, trouble thinking, and lack of motivation, which shows a greater progressive volume reduction in the brain, which is something I thought is of importance. In all these images here, um, although they're not identifying necessarily, it's not the best examples of the hippocampus and the prefrontal cortex. We see this is healthy, this is healthy, this is healthy, this is healthy. In all the MRI images with people with these diseases, the volume in the brain is decreased. There's the dark spots. Um, there's more darkness in the images, which is showing cell death. Um, which again, without neurons, without cells, dying cells means less neurons, means weaker connections in the brain. Confabulation in the brain. Now, some important regions, uh, like we mentioned before, the hippocampus, damage here can disrupt accurate encoding and retrieval memories, leading to gaps that confabulation can fill. The amygdala dysfunction here can lead to inappropriate associations with confabulated memories, so making something that's not real feel real. The prefrontal cortex, this allows for us to distinguish um, relevance and irrelevance in memories, um, and true memories from false ones. And the anterior cingulate cortex, which, as mentioned before, is important for error detection and conflict monitoring. So without this, erroneous, false memories are slipping through the cracks because they're not, nothing's there to detect them. I have this image here just because I think of it almost as um, uh, these these regions and these connections are like roads, especially for our memory. And when these regions are not functioning properly, uh, the roads kind of split. Okay, where memory goes wrong. Here, there's a lot going on here, but to focus on the left, patient HM. This was a man who, back in the middle of the 1900s, yeah, 1900s, he had severe epilepsy and underwent a surgery to have his hippocampus removed. This was back when this was allowed. Here we have normal brain, HM's brain with the hippocampus removed. His epilepsy was cured, but he could no longer form new memories, which was um, and he played an incredibly influential role in neuroscience, especially memory and what the regions involved in memory are. Um, with this, we see that the hippocampus is incredibly important for um, encoding and consolidation because with this anterograde amnesia, without the hippocampus, new memories cannot be formed. On the other hand, trying to recall, retrieve memories, retrograde amnesia, which is when we can't remember things in the past, Alzheimer's disease, and confabulation are all diseases that can uh, affect retrieval. Signs of memory deficit. So if you're frequently forgetting things, if you have difficulty with daily tasks, if you're often confused, changes in mood and be if you're experiencing changes in mood and behavior, uh, maybe assess yourself. Uh, why have I been so forgetful? Lots of things can make us forget. Stress, uh, a busy life, lack of sleep. Uh, as long as you're not noticing serious changes in your personal or social life, um, you're probably okay. But doesn't mean you shouldn't be protecting yourself. Which leads to my next slide, protection. So, with all these memory deficits and these diseases, how should we stay protected? Stay mentally active, maintain a healthy lifestyle, eat a diet rich in healthy fats, vegetables, fruits, variety, moderation. Identify chronic conditions if you or your family members have, um, mental or physical illness history. Be aware and take the necessary precautions. Socialize, although it may sound easy and maybe even a little silly, socialization has been shown to improve our physiological health. Uh, Protect your head. Wear a helmet if you're riding a bike or a skateboard. Um, don't jump off anything too high. Uh, um, be careful. Do friends really help? Yes. How do I exercise my brain? I recommend doing the Wordle, the crossword. Read before you go to bed instead of looking at YouTube. Um, Stay away from drugs and alcohol. Um, Practice mindfulness. Yeah. And just to revisit our learning objectives, I hope now you have a basic understanding of memory formation, a basic understanding of brain regions and the involvement in memory and their involvement in memory, causes and implications of memory deficits, knowledge on how to spot and protect against deficits. What now? Uh, I hope you learned a thing or two, and I also hope now that you step into your life a little bit more conscious of your memory, um, and your mental health. Thank you.